Okay, so today our agenda point is to understand the concept of stateful applications uh, in the form of container. We discussed stateful application concept in detail in previous lectures, but today we have to implement the stateful application in the form of container, and we have to understand the concept of environment variables we can uh, provide to a container, and what is the purpose of environment variable. And then we have to look into the Docker Compose, why Docker Compose, and what benefits Docker Compose can give us. Why not only by the command line we use to run the containers. So, and the third thing is we have to get a detailed idea how this Kubernetes architecture will work. What are the limitations in Docker? A simple Docker, a standalone Docker that are not mean why we cannot run a simple Docker in the production environment. What are limitations? So let's start with the stateful application. So for the stateful application, we discuss there are two types of stateful applications. Please mute your mic. Uh, there are two types of stateful applications. One is database. Database is always a stateful application.
Screen doesn't mean
Screen is not shared. Screen is shared.
No, his screen is shared, but he is not able to see it. I think he might have internet issue.
Well, let me stop and share again. Obashir, you please mute. Some people are unmuting. That is making problem. So please
Yeah, I'll
mute
do
them.
so.
I think you can do this.
Yeah, I can.
Okay. Okay, you can screen is shared now.
Yes, it is.
Okay, so stateful
I
applications we
am
discussed there
I
are
am unable to watch.
no screen is shared. Everyone
Not
can
Uh,
shared.
see the screen.
Not shared. Thank you.
Okay, so
yes.
the database is a type of stateful application, and there is other type of application, just like you have some web application that is saving data, some user data in the form of unstructured data. You can say images or PDF file or any data that is uploaded by the user. That will not mostly save directly into the database. This is possible. You can save any uploaded data by the user into the database, just like unstructured data, MongoDB. Uh, the NoSQL databases are mostly used to save the application, end user actual uploaded data into the database as well as its metadata. But metadata means the data about data. What data is uploaded is saved in the database. So, for example, you have an application, a data user is uploading the data. So it depends on the architecture of your application, how that application is designed. If everything is going in the database, data and metadata both are going in database. So then you don't need to make any persistence volume with your application to save the uploaded content. But if this is not the case, then you must have to attach a volume with your application container too. Database will obviously mandatory will have a volume to save the whatever written in the database persistence. In case your container state lost, your data will be preserved in the volume. So what I mean, so if I draw this diagram, we discussed this earlier, but if I draw this diagram again, I mean, this is your container, for example, application container. Whatever application is, it can be PHP or Java or Node or Angular or Python or whatever language you use. And this is your database container. So database must need a persistency. So you will definitely attach the volume with this database to make the data persistent. So whatever you will write in the database will go in the but if the application is saving data in the unstructured data too, not in the database, then you will connect the volume with your application container too. So this is very simplest architecture. So in this case, when the application is saving data in a volume for the persistency, in this case, you can launch another container. Okay, by using the same image, and you can attach the volume to the same store, to the same volume. Now both application can see the same data coming from the volume. Okay, you can launch another container. Okay, it's smaller in size. You can suppose like its footprint is less, mean it's taking less CPU RAM. But all these three application containers are sharing the same data from the volume. If you run the multiple containers with a -v option, and all are pointing to the same volume, they will have the same data within the application, and whatever the application you will access, you will get the same data. Okay. This is a situation where your code, for example, this is a code. I just highlighted this code with, I can say this yellow color. For example, this is the code of the application or the uh, final artifact you uploaded in your container. This is the code. This will be static. This will come within the container. Whenever the container will launch, this will automatically be available inside the container. But in this code, somewhere is written when the end user will upload the data, it will save in some directory, and that directory must have to be associated with this volume. Okay. So in this case, this you can say this is a stateful application and it is saving data centralized location, but all applications can see the data at the same time. Now look to the DB. When you start a database server and you point all your database files to the volume, when the database server will start, the data files will be locked. Okay. And if you launch another container of database pointing to same volume, this will not work. When the second container will start, it will give you error that these data files are already locked or data files are already in use by by any other database instance. So in this case, only one container will run fine. So you cannot run the database like this with the same volume. You must have to attach a separate volume. You must have to attach a separate volume for each database. Now, for example, this application, these all applications are connecting with this database. Let me change the color. This green line. So these all applications are connecting to database. Okay. And these all applications are writing data to this database. So how the second database will know that this data is updated? So one thing is you will, this architecture is also good. You can enable the data replication. Data replication, I can use an arrow. You can enable the data replication among two DB instances. In case this DB crash, the second DB will have the recovery of last point in time. The last transaction, the insert, update, or whatever changes made in the database schema or data will be preserved to your second database. Okay, because everything is going in there. And if these applications all crashed, your uploaded data is available inside this volume. So this is an architecture where we understand two things. Uh, a state full application of database cannot share the same volume. They must have to replicate and they will have their independent volume. Okay, you can create multiple database instances. You can replicate the data, enable the replication of data among all databases. Database replication is provided by all databases, Oracle or Postgres or MySQL or MongoDB or whatever database you use.
So Daniel has a question. So can you take that?
Yes, Daniel.
सर एज यू सेड दैट एक वॉल्यूम हो सकता है तमाम एप्लीकेशंस के लिए, तो क्या इसमें वो एरर नहीं लेगा? बिकॉज लेट्स से मेरे पास एंजिनिक सर्वर्स ही हैं, मतलब मैंने तीन एंजिनिक सर्वर्स हैं और उनकी के जो मतलब लेट्स से जो डेटा राइट है, क्या उनकी लोकेशन अगर एक ही हो तो उस वॉल्यूम पे वो मतलब कॉन्फ्लिक्ट नहीं अराइज करेंगे, मतलब इसका कुछ नहीं होगा? और लेट्स से जिस आपने बताया डेटाबेस में एक ही होगा तो उसने उसको लॉक कर दिया, so we are using the database for the replication for security purposes. तो क्या इस तरह मतलब इसमें कॉन्फ्लिक्ट नहीं आएगा एप्लीकेशन में?
What type of conflict? Any
लेट्स से
example?
आपने एक एग्जांपल कोई दिखाई थी ना, मतलब पिछले लेक्चर्स में, कि मतलब आपने एक वॉल्यूम अटैच किया था वेब रूट के नाम से, ठीक है, और एक पाथ लिया था बेसिकली जहाँ पे वो वेब सर्वर्स बेसिकली वो जो HTML फाइल्स होस्ट हो रही थी बेसिकली। तो अगर यहाँ पे भी इस तरह किया जाए, तो अगर इंजीनियरिंग सर्वर्स ही तीन हों, ठीक है, जैसे ये एप्लीकेशन और तीन इंजीनियरिंग सर्वर्स हैं यहाँ पर ले लूँ, तो उनके जो पाथ्स हैं तो वो तो तीनों सेम है, तो क्या वो मतलब लेट्स से जो वेब रूट और उनके दरमियान जो कनेक्शन बिल्ड होगा, क्या उसमें कॉन्फ्लिक्ट नहीं आएगा?
No, no conflict.
Um,
Because this application is not making any lock on the data. This is just a shared data.
ओके, सो मतलब ये अपना अपना एक अलग अलग फोल्डर्स इस वॉल्यूम में क्रिएट करेंगे?
नहीं, सबका सेम है.
अच्छा, सही सही, ओके।
एक या whatever you will place in this volume, it will be reflected in all containers.
हाँ हाँ, दैट्स फाइन, दैट्स फाइन, दैट्स फाइन, ओके ओके ओके।
Okay, so then in case of database, you must have to enable the replication. Okay, and for example, if I give you another example, or in this case, one database will be master and one database will be slave. or you can set up a load balancer on top of this database. For example, this is your load balancer. All the applications will point their data source connection to this load balancer. Okay, now this load balancer is sending request to databases. So this database is master, this is slave. Slave can only read the data. From slave database, you can only read the data. From master, you can read and write. So this is the responsibility of this load balancer to write, to send the only read request to this master, all read request to both, but only write request to master. So this can also be architecture. You can also set up the databases replicated. I mean, database replication is already there. Database replication is always there. And there is also a type of cluster in the database of master. All the databases are master. All the database can write simultaneously. In that case, what will happen? The replication will be two-way. Whatever is written here will be replicated here. Whatever is written in DB1 will be replicated to DB2. Okay, so this is a complex architecture. I mean, when you are running multiple databases and they are all are master, this is very complex and also difficult to uh, configure. So mostly people are using master-slave architecture. The load balancer will automatically decide. But in that case, if master is crashed, you mostly have to update your slave, mean the slave as a master manually. It can it can also be automatically, but in most cases we have to do this manually. But it will at least provide you the last point in time of recovery and loss of data. You can avoid the loss of data. Okay, so this is the architecture of two type of stateful application. One is database is always a stateful application, and a normal application is stateful because it is also saving the data. Now we will do this practically. For the practical, what we can use, if I go to Docker Hub and search for the database, for example, we can start with for example, MySQL. So MySQL is basically official version by Oracle now. MySQL is owned by Oracle. So we will use a MariaDB. You can also use MySQL. But MySQL, you can take the support from Oracle. So this is the MariaDB database. Okay. So to pull this image, I will use this command. It will pull down the latest version of MariaDB and how to start the volume. This container. I first of all need to make an understanding where this volume data be pointed. So I just need to, it's normally var lib MySQL within the container. I want to see here where the volume is mapped. This is the configurational directory. If you want to make the persistency in configurational changes, you will map the volume like this. This is the example for var lib MySQL. So within the container, all the data files are going under this location. All the databases data is saved here. So Now what I will do, Docker images. For example, I want to use DB data. I see. This volume will automatically be created by the Docker instance service, and within the container I am using this path, or you can use the relative path too. Some different location. For example, don't want to create a volume live from Docker, you can create just like opt slash db data. It will create a directory at this location. This is the image. We can also do the port forwarding. For the MySQL port, MariaDB port is 3306. I know 3306 is not occupied on my host machine. That's why I use the same port. So this container is not started. This is in exited state. Why? How we can investigate Docker logs. So I checked the logs why this container was failed. So you can see the entry point. We discussed this entry point in detail. This is the point of starting the service. So it is starting some script in this container, and this container has database version 11.4. Okay, it's based on Ubuntu. Okay, the service started. You can see now C group. We discussed C group is basically defining the limit of resources, CPU, RAM. So this is also mean not writable, mean we have not defined this. Okay, the error. These are all the normal logs. But the error came, database is uninitialized and password option is not specified. You need to specify one of these all the variables, okay, are predefined within this container that will be used by the entry point script as an input. So if you go down, you can see here the volume environment variable. So you can study all these environment variable. What is the purpose of these environment variable? So at least we must have to provide the root password for database user. So for example, we can use the multiple environment variable. For example, I can they mentioned only these environment variable, but we can also create the database user with the environment variables. So, okay, let me just use this only one environment variable. To use this environment variable, what I need, first of all, I will remove this container, again run this same command and use -e. -e is used to define the environment variable. So this environment variable I am going to use with some password. For example, I'm going to set up some password. set this password for this environment variable. This environment variable will take an input, will be the input for this entry point script. And this entry point script will take the value from this environment variable and will define the MySQL root user password to this password, whatever I defined. Mostly you will use the environment variable values within the quotes. So when you are using the special character, it is making problem without quotes. This time database is started so far, not crashed. So let's see the logs. And you can see the live logs by -f such. So what happened? You can see this time entry point. Here you can see the entry point. Okay, service started, and it is initializing the database. There is no error. Okay, MariaDB ready for the connections. So service is started on port this within the container, and you can make the connection. So now Docker PS, this database is running on my host machine, and this 3306 port is open. Okay, so now I want to make the test this database connectivity. So what I will do, I will enter in the container. I believe bash is there. Sometimes you will not get the bash within as a command inside your container. Then you can use sh. Now we are inside the database container, and if we look into the var lib MySQL directory where we point out all our persistency, data volume persistency. So this data is written here. It's mean this whole data is also reflected in the volume. Okay. Now how we can connect the MySQL? MariaDB has its command line utility to connect with the database. Each database has its own syntax to connect with the database. Basically, MariaDB is the client utility we can use to connect with database. So since I am inside this container is also providing the client utility. So if you want to connect this service from from other container or any other look from any other location, you from the command line, you need this utility. So I am connecting with the root user of this MariaDB, and I will provide the same password what I set up during the setup of my container. And that password, by using that password, I can see I am logged in. I can see the version of the MariaDB. Okay, so here, this is the syntax of database. You just need to understand how this, how to administrate a MySQL database. Show databases. Show databases is a MySQL command that will show you all the databases. These are the built-in databases. Okay. So for example, I want to create a new database. Create database. For example, app1db. Create. See, I think hyphen is not allowed. The new version of databases are not supporting hyphen. You can see this app.db is created here. Now you can create the tables inside the, and whatever the schema is provided by your developer, you can import it here. This is another story. But I just create a database. I exit from here. Now I am inside the container. Actually, I was inside the terminal, the command line of database. So now, you know env command in Linux. So why Linux administration is important before understanding these all new container concept. So because you must have a basic idea of Linux administration. So env is the command that will give you all the environment variable exposed within your operating system. So you can see this environment variable is reflected here. Okay, and now this environment variable is used by the service started. So I write ps minus aux mariadb d instance service is started. It is this service use this environment variable as an input. The rest of all are environment variable related to the operating system, the container operating system, file system. So now our database is up. If I go under the OPT and I look DB data, okay, so this data is created by, this directory is automatically created by when you start the container. And you can see the ownership of this DB data is uh, LXT and group owner is Docker. If I look into the ID of LXT, its ID is 999. Okay. Okay. And I look into the ID of this group. So grab this Docker slash etc. Its ID is 999. Okay. Now I will go inside the container again. Var lib MySQL. This directory will map to this location. So now here you can see here the volume. This directory has ownership of MySQL. If I run the ID of MySQL, its ID is 999. This is the group. Its ID is 999. So what happened when you actually this directory is owned by MySQL. MySQL has ID 999. So with the 999 ID, user ownership and group ownership, this directory is created. But MySQL user with the 999 ID is not on my host machine. But on my host machine, 999 ID is occupied by LXT user and Docker group. So that's why it is reflected here like this. So you don't need to worry why it's coming like LXT. If there is no user with the ID 999, it will only pop up here, print out here the 999 ID only. So this is mapping because the Linux is mapping the ID with the name. So in fact, this is MySQL user and group. Okay, so this was all about the volume we created. Now, this concept we discuss here mean we cannot use the same volume for the multiple databases. So what I will do, recall the same command. Okay, what I will change here, two things I cannot reuse. The port I cannot reuse because this is already occupied. I change port to 3307. Environment variable, okay, no problem, it's good. And container name cannot should also be different. So rest of all, I think I use same. I use the same volume. I use the same within the container, new container by using the same image. Okay, Docker PS. You can see this is started. Let's see what happened. And if I see the Docker logs, you can see an error occurred when this entry point script started. Okay, this entry point script started, and under the var lib MySQL directory, this new container also found the same data. And here the MariaDB startup service cannot lock this control file. This file is basically the control file, and this file is already taken over by another service. So it tried multiple times to occupy the lock but failed. Okay, could not exclusive lock. So this error is related to MySQL. When you will run a different database, Postgres or Cassandra or MongoDB or Microsoft SQL or Oracle, you will get the same error in different way, but the syntax you will get the same error, like the lock is already occupied. So now if I look at the containers, you can see exited about 1 minute ago. So now both containers are pointing to the same volume that is making the problem. Now what I need to do, I will, so now this is a different story. How we can, if I create this container, the second container with a different volume, for example, DB, sorry, I wrote here that date, it should be data. So, and I will, this time it will be started because now it is using an isolated container. Look into the logs. What mistake I did? Oh, sorry.
Volume name is same.
Yeah, volume name is same. Volume name is same, and I need to also delete. Even I'm using Control C. Okay, 3307. Okay. And this time it is started properly. So if I go under the OPT, I can see this DB data 2 has its own directory structure, data files. And if I go to DB data, I think date I mistakenly mentioned here. So here you can see an additional folder for app1db I created for in the first container. But this is a new container. It is not containing. It is only containing a default database, MySQL Performance DB and sys. So now you have to make the configuration and enable the data replication among the containers. This is a different thing. But here we are just going to understand the stateful application. So we got the idea how stateful applications in the form of database are making locks, and you cannot reuse the same volume. Okay, but quickly, if you give the idea docker run -d web1 container I use with the volume under the OPT, I use web app and I map it US for example 81 to port 80. Nginx, this is a volume, and okay, I run multiple containers pointing to the same volume. Sorry, it will, yeah, yes, yeah, now I have to change the container ID. Now these three containers are running. If I go under the OPT and here web app, and if I create here index.html, which is showing me the just I think I used the wrong path. Oh, this is a mistake. USR, I have not put the slash. That's why it's going to the wrong path within the container. Okay, so you can see now the container one is looking to this file. Container two is also getting the same data. Container three is also getting the same data. In this case, there is no lock, but they are using the same web root. Okay, so now one more example I can give you for the stateful application. For example, I can use Postgres. Postgres, you can see Postgres has its own environment variable, and here you can use multiple environment variable, Postgres user, Postgres DB. Let me just quickly set up this container. By using this password, using this container. Sorry, but I did wrong. I must have to do a volume mapping. Volume mapping under the OPT, for example, PGDB1. And within the container, it will point to So this is the directory that is containing all the path is a local volume from the container name. Thus, data is not persisted.
What is this minus D at the end of the command for Postgres? We are using minus D 2 times in a command.
Yeah, this should be one time. I mentioned here too. I have not seen this D. That's why I add here. I think it will give us error or other PS minus a Postgres is started. If I look into Docker logs, Postgres one. Okay, it started. You can see system is ready to accept the connections. And if I start the same container, say using the same volume, with a different name, name, port I have not exposed. This is a problem. You can see it is not writing the data. I think both containers are not able to. Data files are not created. I think I map the actually the problem is you can see this. Okay, let me go inside the container. Inside the container, the path. Yeah. Why the both container ran? Because this volume is not mapped on the host machine. Only this directory is mapped, but this data is not pop up on the host machine, I think. Let me now go back to here. I cannot see the data, but within the container, I can see data. It's mean I need to map till data. Okay, let me.
अस्सलाम वालेकुम सर, इसमें स्पेस आएगा, कॉलम के बाद स्पेस आएगा तो वॉल्यूम माउंट हो जाएगा, आई थिंक यही।
नहीं, स्पेस नहीं चाहिए। Now you can see the Postgres data is reflected here. So I mounted the wrong volume path. Now I will start the another Postgres pointing to same directory. You can see here the error message came not properly shut down. I mean, the logs are already available. I mean, MySQL gave us this error in different way, but here we have a different type of error. It will crash after some time. It will make some time. Every database has its own way of starting services. It can take some time, but you can only use one database at a time. So this was about the stateful. So now your job is you have to complete all the databases. I mean, mostly you should know database about the MySQL, Postgres, Microsoft SQL
हमने
database.
कहा क्या इनको जो भाई की इतनी नफरत है,
ये
असदुल्ला ने
Microsoft
बात की वो
ये
हमारी गली
माइक
डाल दी।
माइक म्यूट कर दें प्लीज यार। माइक्रोसॉफ्ट
बच्चों से जिसने
एसक्यूएल
रखी हुई है उसका इलाज करवाने जा रहा है।
ये माइक म्यूट कर दें यार, ये क्या कर रहे हैं?
कर दिया।
अच्छा, ये मतलब if you are coming in class you should focus on the class. You are doing the other stuff too. Okay, so what I was doing, yeah, I was giving you the idea. Docker Hub, where is Docker Hub? This is Microsoft SQL database. I don't know exactly what is the name. SQL. You know, Microsoft SQL is also supported on Linux now. So let me check. I don't know exactly what is the name of database. Let me just quickly SQL DB container. Yeah, Microsoft MS SQL Server. Yes, this is the exact image name. So this is the Microsoft published. So you can also run, and this is not a free database. So here you will get a challenge of licensing. So Microsoft SQL is providing Enterprise Edition. In that case, you need license, and you can also use Evaluation Edition or Developer Edition or Express Edition. That is free, but that will limit your data size, I think, up to 5 GB or 10 GB max. So in that case, you have to read these environment variables. You can see MS SQL PID is the environment variable. You will define what type of lessons you want to use. Okay, so MySQL, Postgres, Microsoft SQL, and MongoDB. Okay, this is, and what else we can use? We are using mostly Oracle. Oracle you can also run within the container. Oracle Linux is providing there, and you can create the cluster among the database, Oracle databases using this microservice. And
Cassandra.
yeah, Cassandra. Yeah, Cassandra is also NoSQL database. This one too, and one is Cassandra. Yes, Cassandra it was. Cassandra has its own built-in cluster architecture. So you need to understand the documentation. And basically, this image is very old. I think Cassandra you can only pull from its local repository. Docker Hub is not providing Cassandra.
No, there is a typo in Cassandra. So Cassandra, not E.
Yes, this is Cassandra. So this Cassandra, when you will start this, I think it will by default give you the clustered architecture, I think. Make a cluster, you can see. So by default, it's Cassandra architecture is very good. It's a concept of rack, and within the rack, it is placing multiple instances. They are all synced, and you can create multiple racks across different data centers with the replication. Just like we use MySQL D, MariaDB D, this is the command line utility to connect with the database. Okay, so this was all about the databases, stateful application. Now we have to look into the second topic, the Docker Compose. If I go to Docker, docs.docker.com, and here I will search Docker Compose. Docker Compose overview, Docker Compose quick start, CLI, installation. Okay, so Docker Compose overview. So why we need Docker Compose, first of all? You know, we ran all multiple containers. So first of all, let me remove all these containers. So we ran multiple containers, and we use multiple commands to run these containers. So if you want to run, for example, hundreds of containers, you cannot memorize all these commands. It's a good idea. You can write all these commands in a bash script, and you can run those bash script. It will create all the containers, but Docker recommend to use the Docker Compose when you are setting up multiple containers, mean multiple applications. For example, you are hosting multiple application within your Docker server. So you will create multiple Docker Compose files, and each file will contain the containers. And the benefit of using Docker Compose is it is automatically creating a network that associated with those containers, and all your application will be isolated from other application running in different Docker Compose environment. So Docker Compose overview, if you look at Docker Compose as a tool to defining and running multi-container application. It is a key to unlocking a streamlined and efficient development and deployment exercise. In every new application will go under a different Docker Compose file. What you can do with the start, stop, rebuild the service, view and status of the running service. Okay, logs, everything you can manage by this Docker Compose. If you remember when we install the Docker when we install we basically what we did on the CentOS, or I think initially we used CentOS. So here this command we use we install Docker by using all these packages. So we use Docker CE Community Edition, Docker CE CI command line, container DIO. This is the core runtime engine of the Docker. Docker build X. This is used to build when we build the container Docker file. This package provide the functionality. And the last you can see the Docker Compose plugin. This Docker Compose plugin is providing the functionality to run the containers under the Compose. So at the time of installation, we blindly copy this file and install the packages. So now we see that we also install the Docker Compose. Okay, so Docker Compose we have, it's mean I can run Docker Compose as a command. Okay, so for this reason, what I need to create a Docker file, a Docker Compose file. So well, here we had an idea of Docker Compose overview. So this is a quick start. You can read this whole documentation. Here is a very simple example. They are using some Python application. This is the code of the Python application. I don't know exactly this Python application is doing, but what they did, they create this Docker file to run this Python application. Okay, and they start the service of the Python application by using CMD. You know about this Docker file. So this is a Python based, and they use the base image as Python because Python 10.3.10 already installed it will be available in this image. Defining service in the Docker Compose file. Now this is the syntax of writing the Docker Compose file. On top we will write services. Mean each container will run as a service. Each container will be represented as a container. So here you can see they set up two container, web and Redis. So this is a web and they are using build. This I will give you idea with a very simple way. This is complex. It is building on the real time. And I want to show you the exact syntax. So this is a service, and then we will define our image and container name and the port and volume and everything we can define here. Okay, and Docker Compose CLI, these all tools we can use, these all commands we can use with our Docker Compose command. So let me write a very simple Docker Compose. For example, I am going under the OPT, and here I can create a directory app1. Inside app1, I will create a file docker-compose.yml. So this file, this file I am going to create is this is a syntax of the Docker compose file name. You can use a different name too, but this is the default name, and its syntax is YAML. That's why I use .yml. In Linux, there is no extension. This is just a representation. So here, what we have to use a service, and indentation is imperative in the YAML when you are writing. So I use two spaces, and I already set my tab to two spaces. I believe there is a .vim. This is the default behavior of Ubuntu. But you can, in CentOS, you will not get the tab to two spaces. There is a way in the VIM. You can see in the VIM documentation how to set the tab space to 2. That will help you to edit the Docker file. So I'm going to this directory. Here I'm going to create a Docker compose file. And here I defined the service. And under the service, I will define, for example, my first service name is web. For example, front end. Service name is front end. Under this service name, I will define the image. For example, my image is Nginx. And the container underscore name, I don't remember exactly the syntax. When the error will come, we will fix it. For example, I can say front. Mostly I am using the name of the service and the container name same. You can use different, but when you will use the same, it will make very easy for the troubleshooting. Okay, this is a container name, and what else we can use? Okay, simplest, we will start this, and let me start this very basic container. So right now, what I defined inside my Docker Compose a very first service name as front end, and image I use, and this service will run as a container, and the name of the container I defined. Now what I will use Docker compose up -d. It will start the containers in the daemon mode. If I am not using -d, it will run in the foreground, just like if you are running container Docker run without -d. What will happen? It will show you everything about the container logs on the terminal. When you will do the Control-C, the container will be exit. The same -d is doing. All the services defined under the Docker Compose file will run as a daemon mode. So where I defined, when I will press enter, there is an error. Root additional property service is not allowed. Okay, I did a mistake, syntax mistake. Let me check. Web and image, and I think, okay, let me just, I think this container name I provided wrong. But I am deleting this one. Additional property service is not allowed. Validating. I think this is services, not service. Yes, S is missing. Services. And I don't know exactly, this is underscore or hyphen. Yes, this is created. So you can see this container, this service is started. And two tasks done by this Docker Compose. Network is created with the name app1 underscore default. A network is created and a service is created with front end. If you look here now, Docker PS, you can see the container is running. This container name is front end, whatever I define. But how this ran by Docker Compose. I can also see with the Docker Compose PS. So Docker Compose will give you all the services created under this Docker Compose. Okay, so you can, when you are managing the Docker by Docker Compose, you will use Docker Compose instead of Docker PS. You can also use this, but this will make a confusion. So when we will create the multiple Docker Compose, you will get the idea how this is making a benefit for us. So for example, I run the Docker network ls. You can see a dedicated network is also created. And this network, if I Docker inspect this network, you can see the container automatically front-end container is associated with this network. Okay, and this network automatically gain the new IP range, whatever was the freely available. Okay, let me add one more service here. So this is my first service front end. Okay, for example, I have another service. Backend image, for example, HTTPD, and container name. Backend, I use the same container name. Now what I will do, Docker compose up -t. So it will only start the containers that are not started yet. We look at Docker compose up PS. So two services are running. Okay, so if I run a Docker PS, it is also showing me the two services running. Two containers are running. So how, if I run this command from this location, to a different location, it will not run. Why? Because when you are running this Docker compose command, it is basically searching the docker-compose.yaml file. If this is not available, you cannot run this Docker compose. So you must be in the same directory where your Docker compose is. Okay, otherwise you must have to, if you are using something like this here, you use Docker PS, it is giving you error. Then what you can use, -f provided by opt. I think it auto completion is not working. F1 slash so now you point out to this YML file for from any different location. Okay, otherwise when you are in the same directory, you must have to, you don't need to specify. And if you have not used this standard file name, In that case, you also have to provide this, because this I use the Docker Compose as a standard file name, automatically sensible by Docker Compose. And okay, so now I will make this Docker Compose more complex. What I can do. This is a name. So what else we did? We can use the volume. I believe the syntax of the volume is like this. So volume I can do, can create a volume like OPT, and under the OPT or at the same location where my Docker Compose is, I can use // it will create a directory. It will map under the this location. And for the port, I don't know exactly port or ports. Usman, or you can please check what is the exact syntax of Fazil. Port I can specify 8181.22.
Supports, not port, it supports.
Okay, this is volume or volumes?
It's all.
Okay, and
Sorry.
what else we can
Sorry,
use?
it's volume, volumes. Sorry, it's volumes.
So whatever changes I am making, I will just do must be ports. There is some syntax error. Volumes must be a listed. Now there is syntax error. What I think it is something like this. You can go to this documentation and you can see there sometimes they are also giving the Docker Compose example. For example, in the MySQL, this is the example. You can also add a restart always. Okay, let me add this, because whenever the container will crash, it will start automatically. This is also your ports. Ports is like this, and volume. Ports is good. Let me just remove this volume. Yeah, now it's good. It need an indentation with the hyphen. Now your Docker Compose PS both container are running, and you can see here it create a web root directory automatically pointing to our one container. Similarly, you can use, for example, I define a volume. I can define environment variable. So this environment variable will be reflected inside your container. Here I saw an example like environment. I believe there must be a hyphen and variable name I can use, for example, symbol variable one. Its value is 1, 2, 3, 4. Another variable I can define variable 2. So in case of container, if you are doing everything like with the command line, you must have to stop the container and remove the container to make any change. You cannot make any change in the running container, but Docker Compose is giving you the facility to modify the things on the fly. There is some syntax error in the environment. I think I cannot use a hyphen with the environment. Yes, hyphen is not there. So now you can see Docker Compose. Yes, Docker execute IT. I am going inside this container bash. This is HTTPD I use inside the Nginx front end. These two environment variables are reflected within the container. So now these variables you can use within your application. Whatever application is running inside this container may need some environment variable. So you can define as it is the variables.
Sir, in running container, we always have to make a new container instead of using a new port or new things. And in YAML file, we can edit a port, and that container will automatically update, I think.
Yes, this is the benefit. You don't need to make any change every time.
Is it possible, scaling is also possible in Compose file? Can we
No,
scale the application?
Docker Compose is not providing scaling.
No, that's scaling. Scale means we scale the application. We have to make the 4 containers or 5 containers or 10 containers at a time. We write the command of a Docker Compose scale, and that container equal to that container, 4 containers or 5 containers. That is possible in Docker Compose.
No, Docker Compose is not providing scaling. That is
Then
not
write the
possible.
command. Then write the command. Docker Compose scale, SCAL, scale, and front end. You have made the containers front end is equal to 4 is equal to 4.
Yeah,
Enter.
this is the command.
Yes. Enter.
Required each container to have a unique name, removing the custom name to scale the service. Okay, so we need to, actually we don't need to provide in this case the container name because it will create a type of its own container. Endpoint, now port conflict is arises. It will create the multiple container, it will scale, but the issue is, for example, Docker Compose, PS. but it will automatically allocate the ports too. And now it's created because port conflict is happening. So this is a new, I think, Docker Compose. In the previous Docker Compose, this was not available. So now it is scale up. So all front end are using, but what port is exposed, how the ports will be exposed, this is a question. Maybe there will be a syntax to define the port for each container, because these containers are not, basically this is a command for your Docker Swarm. In simple standalone Docker Compose, I think it will give you no benefit. The port allocation is now a question.
I just want to know for my idea that it is possible. Okay, so I see that that is possible. Thank you.
Okay, so I scale down to 1. Actually, we are working with this. We scale up the service name with the name of service. Okay, now, okay, so now I will same like this. We can use the database DB container we can create. Okay, so this was a basic idea about the Docker Compose. You can write different Docker Compose file for different applications. So this is your first application. This Docker Compose is there. For example, I am going back. I'm creating a new directory, app2, and here in app2, I will create another Docker Compose file, just like I'm copying. So here I am going to use a different image. For example, here I want to use Tomcat and its web root. I don't know exactly. I'm removing this from this one and backend suppose HTTPD is making a small change. Now here I will run Docker Compose up -t. Conflict backend is already there. We need to change because it is running a container in the backend. Front end also running. So now you see this here we ran the Docker Compose PS will only show the container related to this Docker Compose file. If I run Docker PS, it will show me all the running container. So with the Docker Compose, it will only show you the relative containers. The Docker, okay, and we can also run stop. And now if I run here, Docker network ls, you can see a new network is created. And these containers are isolated from the app1. All are connected. Both containers are connected with isolated network. So let me just quickly do a Docker inspect. Docker inspect. This Tomcat, this is running. they both are connected with the same network. And this container has a different network. Okay, so now these two containers can talk with each other, and these two containers can talk with each other. So for example, if I jump into any container terminal, this one backend will only talk with this front end. So Docker yes, this is the name of the container. So now if I jump into this container, actually it is not providing bash. Sorry, I give twice the name. Now I am inside this container. So this container can reach, I believe ping is there, ping command is not there, apt update. So what IP we inspecting? This IP is reachable. Okay, and the another thing is this by name is also reachable. You can see I ping access the container by name. So this is a functionality of DNS provided by the network. So when we are creating a custom network, this will also resolve, right? I believe we discussed this earlier. So if this container is deleted and its a new container is created again with a different IP, you can access the application by name. So how with this way in the Docker Compose, all the applications are communicating with each other. Okay. So this was an idea about the Docker Compose. I gave you the idea what is the syntax, but you have to study these overview installing CLI. So these are all the commands we can use with Docker Compose. For example, what we use? We only use up. We only use what else we use? We use scale. Okay, we can use stop and we use PS. So for example, I want to stop all the container for this application. I can use Docker Compose stop. It actually not stop the container, but remove the container. It's just like the remove. And if I do a start, it will start all the containers at once. Similarly, a restart. For example, you made some change inside your volume, and that volume is not getting that data is not getting by your application. So sometime you need to restart the container. It will stop and start the containers again. And you can only stop a specific container to like this, I think. No, we can stop There is a command, I don't remember exactly, but you can also do with the specific command. Similarly, Docker compose ports. At least 2 arguments. I think we have to provide the name of the container. I don't know exactly what is this port, print and public port for the binding. I'm using some wrong syntax. Similarly, you can pause. Pause is basically stop. You can see the logs, everything. Now you need to discover this with your own way. Okay, now in this book, what they gave an example in this here, what they use build. Build is also a way. I mean, for example, you place a Docker file in parallel to here you create a Docker file. Here you create a Docker file, and from image, if you say very simple Docker file I wrote. So this Docker file you can write in your Docker compose, sorry, Docker compose file, a new service. For example, service 2. Any name you can give, and you can type here build dot. What this will do, this will use, here you are not providing the image name. So what will be built by the Docker compose, Docker file placed in parallel to Docker compose will be used for building the, will be used, that image will be used for this service. So for example, I use very simple syntax build dot. So now when I will use Docker compose up minus T, so read the file and build the image. Let's see what image. Actually, again, it's used the cache. That's why it's showing the whole time. But if we look at Docker PS, okay, Docker PS, but why container is not working? Port is not mandatory. I think it's only for building. It should also start the container with the name service. Service 2 will be the new container. Attaching the port, how the port will work. I know port is not working. Port is not inside the container, but you can associate the random port. It will not make any effect. Now service 2 is started. Docker compose PS. Yes, the new container started, but yes, it will fail. Why? Anyone can give answer why this failed. Start the service. I think there is Docker compose minus A. Yes, minus A. So Docker compose minus A will give you the containers started but failed. So why this container failed? Anyone can? Because this the Docker compose, this new image build does not contain any service, but Docker file I wrote. In this Docker file, I used Ubuntu. This is a base operating system image. It does not contain any service. So we understand the concept of the life of the container. If the container is not having any service, how that container can survive? That's why it failed every time. So this way you can also use to build directly, but mostly you don't need this type of Docker compose. In parallel, you can put the Docker file. Okay, so just follow this whole documentation. You will get the idea, new ideas about how to use this Docker compose. There are multiple commands given, examples given. Okay, so now we are done with our Docker. So now we are just taking a 5-minute break, and after break we will resume with the basic architecture of Kubernetes. From next session, we will implement Kubernetes practically. So we will see today what are the limitations in simple Docker, this Docker server, why we need Kubernetes, what is Kubernetes architecture, what components are there.
Assalamu alaikum. Asim, I have question for the Docker
Yes,
compose.
please.
As we discussed for the front end services, so for the front end we have the certificate authorities, and we have from the accessible from the outside. Can we, if we populate this service, can we integrate with the LDAP, or and also if the certificate authority is something not that is the publicly very sign or something like that. So these in the compose where we have to write everything, right? Or and especially my question is for the integration. We have to configure accordingly, right? This is the way, or
No, certificate 30 mean SSL certificate you want to offload for the application.
yeah. Once I will type HTTP, as you know, so I want
Right
HTTP
now,
access.
everything is HTTP based. Yes, we can offload the SSL. There are two ways to offload the SSL. Uh, let's see this example. This application is right now having HTTP. Any user accessing this application from outside is basically sending a request to HTTP. Okay.
Okay.
So you want to make this service as HTTPS. So there are two ways. Either you can offload the SSL within this container. I mean, there is Nginx or Apache or Tomcat or whatever the service is running. You can define there within with that application the SSL certificate. Okay, and then you will write HTTPS, and then you will expose the port 4432 in parallel to port 80. So every time when you will build the image, you will provide the public and private certificate too. That will go somewhere inside the application directory, inside the container, and in the configuration file, you will define the path of your public and private certificate. This is the one way, but this way is not used to offload the SSL in professional life. This is one way. In professional life, what we are using, basically we will set up a reverse proxy. A reverse proxy. So we will set up a reverse proxy. All the requests will first come on this reverse proxy. And here your SSL certificates are available. And then this reverse proxy will send requests to all application servers. So this reverse proxy you will configure along with the name, DNS name of the application and the SSL certificates and the where that request will go on the backend. The most common example of this reverse proxy is Nginx. Nginx is providing the reverse proxy. It will ask you to provide me the SSL certificate and the domain name and the where this certificate request has to route to backend as on the container IP. So this is one example. There are multiple reverse proxy. Traffic is also a reverse proxy engine. Cloud providers, when we will run the Kubernetes, we will implement this reverse proxy. We will offload the SSL certificate in the reverse proxy. And the request, you will send the request by domain name. And so reverse proxy can have hundreds of SSL certificate for different domains. And there can be thousands of containers running on the backend of the reverse proxy. In that case, the reverse proxy will sense the domain name, will offload that specific SSL for that specific domain, and then will only route the traffic on the backend containers associated with that domain only. This we will do practically in Kubernetes. We can also do here. We can implement Nginx reverse proxy in a Docker, and we can route all the traffic first to the reverse proxy, and then that traffic will be routed. Are you good?
Yeah, yeah. And the second part of the question, so if we, if the, for example, if you, can you please show the diagram again?
The paint. Okay.
Yeah, which,
Hmm.
yeah, example. Okay, for example, our application, someone application is outside there, placed there, and I want to talk my application from this application to outside the Docker, some that is the physical machine, and that is the outside in my LAN. So how so will the IP will be changed or what?
I'm giving you example. For example, IP config. This is my computer gateway. I don't just a minute. 1.1.1 I think is my Wi-Fi gateway. Okay, so 192.168.1.1 is my Wi-Fi gateway. If I go inside some, in which container I just install the ping command. Use the bash. It's this one. You can see my container can talk to the external network.